Hi, everybody. This is Miss Moriarty, and I'm here to discuss with us topic 7.7 and 7.9. So, here in topic 7.7, this is all about acid rain formation. Now, you can see in the image that I have to the left here, it is acid rain that forms due to two types of primary air pollutants. Remember, primary pollutants are oftentimes air pollutants that are emitted directly into the atmosphere, while secondary air pollutants oftentimes form due to those primary pollutants reacting with things already found in the atmosphere. So those two primary air pollutants are sulfur dioxide and nitrogen oxides. And recall, they can come from anthropogenic sources. They can also come from natural sources. Nitrogen oxides, remember, can come from motor vehicle emissions as well as fossil fuel or coal burning power plants, while sulfur dioxides oftentimes are going to come from coal burning power plants. And just note that you need to know the chemical equations that you see on this image here. So you need to know that that sulfur dioxide is going to react with water vapor, and that's going to turn it into sulfuric acid, while nitrogen oxides react with water vapor to create that nitric acid. Now, acid deposition is going to mainly affect communities that are actually downwind from that coal burning power plant. And you can kind of see that in the image to the left there, right? You have an area where there's lots of a large concentration of, say, nitrogen dioxide. It's going to be carried typically by wind. We see that it's going to be soluble in the water vapor found in the air. And over time, what that's going to do is it's going to rain and it's going to potentially acidify soils, bodies of water, and maybe even corrode human structures. Now, hydrogen ions are then going to be displaced or leach other positively charged nutrients that are found within the soil. So we know that that's going to affect the productivity and photosynthesis of that given area where that vegetation may be. Hydrogen ions also make toxic metals such as aluminum and mercury far more soluble in soil as well as in water. And lastly, right, we know that it can actually slow the growth or even kill plants and animals living in the soil or water nearby. Now, regional differences in soils and bedrock oftentimes do affect the impact at which acid deposition may have on that region. So if the bedrock actually has a higher concentration of limestone, what that's going to do is it allows it that ecosystem to have a better ability to kind of neutralize the effects of acid rain, since limestone is a more basic substance versus acid rain, which is far more acidic. So how do we go about mitigating acid rain? Well, like I said in the previous slide, we know that limestone is a natural base that can actually help to neutralize any acidic soils or waters. Calcium carbonate can actually react with then the hydrogen ions found in our sulfuric or nitric acid, and that's going to form bicarbonate and give off calcium ions. This actually neutralizes and moves it much closer to a pH of 7, which we know is a neutral pH. We said regions with limestone bedrock have better natural buffering abilities against acid rain. Humans can also actually add crushed limestone to soils and waters to help neutralize the acid. And we also see that acid rain can corrode human structures, right, that we see in the left-hand side of this slide, especially those made from limestone. So just a little overview, right, of where we see kind of acid rain affecting the most areas around the world, right? You can see in orange, these are areas in where we see tremendous amounts of acid rain, while purple areas are polluted air emissions leading to acid rain. So you can see here specifically in, say, like North America, you know, the farther out west here, we see a lot of potential maybe power plants. We know that those emissions are actually going to get blown right from west to east, because remember, we experience the westerlies. And so oftentimes along that northeast coast of North America, we're going to experience more acid rain because all of that is going to be moving towards us. Now, some other things that we need to know. Now, 7.9 is not technically a topic in our APES CED, but it was just something I wanted to make sure that we add because we do need to understand what the Clean Air Act is. So the Clean Air Act was established back in 1970, and there's been updates made to it in 1977 as well as 1990. What this act basically does is it authorizes the EPA, right, the Environmental Protection Agency, to set limits on the amount of specific air pollutants that are permitted. Remember in previous slides, we mentioned that there were 6 criteria air pollutants that the EPA can actually regulate based upon the Clean Air Act. So overall, guys, this is just setting the standard for modern air quality regulation. Individual states are still responsible for meeting deadlines for their air pollution standards. They may pass pollution controls that are much stronger than what the EPA has authorized, but they can't mandate anything that's weaker than the Clean Air Act. Remember, we said it focuses on the 6 criteria air pollutants, such as lead, particulate matter, sulfur dioxides, carbon monoxide, nitrogen oxides, and our ground level or tropospheric ozone. Now, since it's been established, the Act has led to dramatic improvements in the reduction of lead, primarily switching from leaded to then unleaded gasoline. And although air quality is gradually improving, 130 million metric tons of pollutants are emitted into the US air each and every year. Now, the provisions of the Clean Air Act amendments that were made back in 1990 do include the development of super clean cars, which should emit lower amounts of nitrogen oxides and hydrocarbons, also using cleaner burning gasoline. Everyone, in order to kind of wrap up our video, here's just a quick little practice FRQ. Please make sure you read through the FRQ, pause the video, take a few moments, and answer the 2 questions. Okay, at this point, you should have paused the video and answered our 2 practice FRQ questions. So based upon the experimental scenario that they provided to us here, you first had to identify the dependent variable. So here, your dependent variable for this experiment was our concentration of toxic forms of aluminum. Remember, that was what they were measuring in this experiment, making it the dependent variable here. The next piece, you had to explain how the results of the experiment may have changed if the soil sample used contained higher concentrations of limestone. So here are a couple different ways you could have explained that would have been accepted by College Board. But overall, what you should have identified was the fact that our limestone here, remember, acts as a buffer or neutralizer to any acid rain formation or any acid deposition. So take a few moments, evaluate your answers based upon the answer key that I have here. You can provide yourself a little score at this point and just make sure that whenever you are done, please mark the assignment as done on Classroom.